Moving on to Lesson 210, Algebraic Logic Part 1. Yes, we do have to use some algebra in geometry. Please use your course name and section number with all communication with me. The objectives in this lesson is to use proven properties, including properties of equality and properties of congruence, to justify mathematical statements, and to draw conclusions based on given properties, including properties of equality and properties of congruence. Some words we're going to be using in this lesson are direct proof, which is a method of proving theorems in which the conclusion is drawn directly from previous conclusions, starting with the first statement. And we're going to talk a little bit more about a theorem. That's a mathematical statement that has been or is to be proven on the basis of established definitions and properties. So let's talk about properties of equality. You learned these when you studied algebra, and you will make good use of them here as justification for geometric proofs. And this is what you learned about algebraic properties of equality. You have the addition property of equality, where if A equals B, then A plus C equals B plus C. Okay? The subtraction property of equality, if A equals B, then A minus C equals B minus C. And these all are pretty common sense properties. You just need to know the names for them. The multiplication property of equality, if A equals B, then A multiplied by C equals B multiplied by C. And the division property of equality is just a little different. It says if A equals B and C does not equal 0, then A divided by C equals B divided by C. And then last is the substitution property of equality. If A equals B, then B can be substituted for A in any expression. Because when we say they equal each other, that means they can both equal 1, they both equal 2, so that means you can substitute them for each other. Okay, these other properties that we're going to look at deal not only with equality and equal measurement of shapes, which you know is congruence, but also with relationships between several distinct shapes. So let's look at this. This is the equivalence properties of equality and congruence. First you have the reflexive property, and here reflexive is just like, you know, a reflection in the mirror. If A looks in the mirror, A is going to see A, right? So we got A equals A. Then you have the reflexive property of congruence, same thing, except A is congruent to A. Alright? Then we have the symmetric property of equality. This is when you throw in two variables. It says if A equals B, then B equals A. Alright, this one up here could say A plus B equals A plus B. Alright, that would be reflective if you have A plus B equals A plus B. But notice down here, if A equals B, then B equals A. We flipped it. Okay, so that's what makes it symmetric and not reflexive. So, and then the same property of congruence, if A is congruent to B, then B is congruent to A. So notice how B follows B. We flipped them. Then there's the transitive property of equality. And this one is going to be used quite a bit. It says if A equals B and B equals C, then of course A equals C. See how it's kind of common sense? And it works the same when it's just congruent. If A is congruent to B and B is congruent to C, then A is congruent to C. That's how you're going to see it used a lot in geometry, is the congruence. So let's look at some examples. Use the given property to complete each statement. So we're going to use the division property of equality. It says if 4 multiplied by the measure of angle W equals 120 degrees, then the measure of angle W has to equal blank. So let's work that out. 4 multiplied by the measure of angle W equals 120 degrees. So the first thing we're going to do is divide both sides by 4 because we want that measure of angle W to be all by itself. So this is how we're using algebra. So I'm going to divide both sides of the equation by 4. And so these 4's right here are going to reduce to 1. You might want to say they cancel out. And then 120 divided by 4 is going to give me 30. So the measure of angle W is 30 degrees. So that wasn't so bad, was it? Really wasn't. Okay, use the given property, Okay, the symmetric property of congruence. Alright, remember how we're just flipping them? If the angle 3 is congruent to angle 1, then angle 1 is congruent to, now look here, I went ahead and drew pictures for it. This shows angle 3 congruent to angle 1. So all I got to do is flip it. Remember? For symmetric, you just flip them. So I'm going to have the measure of angle 1 is congruent. I said measure, I shouldn't have said measure. Angle 1 is congruent to angle 3. Alright, it says for each problem do the following. A, answer the question. Then B, write the property that justifies your answer. Well, let's read the problem. It says, in the town of Eldersburg, the town hall is the same height as the library. The library is the same height as the shopping center. What can you conclude about the relationship between the town hall's height and the shopping center's height? Well, let's see what the answer is for A. The town hall is the same height as the shopping center. Okay, because remember, town hall, same height as library. Library, same height as the shopping center. So their conclusion is that town hall is the same height as the shopping center. That's a pretty good conclusion. But then what property justifies this? Okay, it's going to be the transitive property of equality. Okay, that's where you have 3 different things that are all the same. Okay, if 7x plus 2y equals 28 and y equals 2x, then 7x plus 2 multiplied by 2x is going to equal 28. I kind of put these up here. It says name the property that justifies each statement. And I put these up here to help us look at it. Alright, here you've got your equation. They've told you what y equals, and then think about what they're doing over here with this 2x. Aren't they replacing the y with the 2x? So you look down through here and you think, okay, which one of these fits that best? And as you're looking, you see the word substitution. It says if a equals b, then b can be substituted for a in any expression. So they're saying y equals 2x, so 2x can be substituted for y. So this is going to be the substitution property of equality. Alright, this next one says if segment EF is congruent to segment PQ, then PQ is congruent to EF. Okay, now this is one that you might get confused. You're thinking, oh, is this reflexive or is this symmetric? Remember, if it's reflective, it's going to look exactly the same on the other side. Okay? Exactly the same. But remember, if it's symmetric, EF and PQ will flip. So see how PQ comes first and then EF? So that's going to make it, oh, not equality, it's going to make it the symmetric property of congruence. Alright, this one says if angle 1 is congruent to angle 2 and angle 2 is congruent to angle 3, then angle 1 is congruent to angle 3. And remember, I told you this is one you're going to use a lot. And notice how you've got 3 different statements going here, and that kind of helps you figure out which one that you're working with. So if you look down here at the transitive property of congruence, it looks just like this statement, except it says A and B and C instead of 1, 2, and 3. So it's the transitive property of congruence. Alright, what we talked about today. The properties covered in this lesson are taught as a part of an algebra course, but they can also be used in geometry. It is important that you are familiar with these properties and understand each of them well. You will be using them over and over throughout this course. So when I say, hey, you can use your notes on your test, these need to be in your notes all the time. What you should be doing after you watch this video, of course, is read through the LMS Lesson 210, completing the study guide. Also refer to the pages 51 through 54 in your reference guide. And work these problems in your problem set. They're really going to help you pass the quiz and do well on it. And if you have any problem with those, please contact me before you take the 210 quiz. And that's going to be all for today, and thanks for listening.